The next question says to us, a school kept records of all the learners that arrived late for school. So we know already we are going to be working with learners that arrived late for school. The mathematical literacy teacher noticed that the late arrival is influenced by the occurrence of rain. So you can see that we get a lot of temperature and a lot of weather probability. We did have a McChicken McFeast one at the beginning, and it says to us the tree diagram below was drawn to show the outcomes. And look at that. In this particular one, now we do have the outcomes. In the first two questions, we did not have the outcomes. So it does help for you guys to always know how to have the outcomes. So it says the outcomes and probability of late arrivals when the chance, and there we've got the chance again, and I said to you guys, chance and probability are the same word, they just said differently. The one is fancier than the other, so don't panic, okay? And it says to us that when the chance of rain is 25%, we are going to be working with some percentage and decimals in this particular question. Tree diagram, again, look at that nice starting point over there. If you add these two decimals over here, it says to us 0.25 is chances of rain, 0.75 is chances of no rain. And if you add the two, it should give you 1. Okay, let's go see if I am correct. That's going to be 0.25 plus 0.75. You see, that gives you 1. And I said to you guys, probability is out of 1 or out of 100. So look at that again. 0.8, 0.2. So chances of rain is 0.25. And if it rains, the chances of people being late is 0.2%. I mean, not percent, 0.2, okay? And then the chances of people not being late is 0.8. Those are the two things that we have in that particular one. If you add those two decimals again, they should give you 1 again. Let's go to no rain. No rain, late 0.1, not late 0.9. Again, 0.1 and 0.9 should give you 1. Okay? And then here it says to us, carrying on and on and on. And you can see the combination that we've been given. This is the outcome over here. It's the outcome. And you can see that they've said R and L. I would be so confused about this. But if I go backwards, I can see R is for rain and L is for late. I am going to erase all of that so that we have a nice clean screen there. So going down, the first question says to us, write down the percentage. And you can see we're not given anything in percentage. So it means we're going to multiply something by 100, like I said earlier. Write down the percentage of learners who arrive late if it does not rain. So it's two things that are happening here. So it's learners who arrive late if it did not rain. So what am I going to do? I'm going to go to no rain, and then I'm going to go to arrive late. So it's going to be no rain and arrive late. So let's go to late and rain. So it's going to be a combination of those two things over there, okay? No rain and late. And that's the outcome of the two things when we have them together. We want that as a percentage. I said to you guys, whenever you hear the word percentage, it's something out of 100, or if we need to convert that, 5.2.1. So it was given as 0.075. And because it's 0.075, I'm going to multiply that by 100 to make that a percentage. Let's go use our calculator over there. 0.0, okay. 0.075 times 100, which then gives us a mixed fraction, an improper fraction, and we have 7.5. The 7.5 that we are looking for. So the percentage is 7.5%. Don't forget to write down your unit of measurement. Why am I writing down my unit of measurement? So I can get all my marks and I'm showing that I understand. The next question says, write down the missing outcomes A and B. Let's look at where A and B are sitting over there. That's A and that's B. And I'm going to try and now find the outcomes. How am I going to find the outcomes? I'm going to copy the rest of the stuff that was given to me. And I say to you guys, you just look at those little keys over there. So for A, it would be rain, not late. So it would be RN. Okay? And then the next one for B, it would be no rain, which is a D, and late, which is L. So it would be DL. So I've got my outcomes going on over there. Free 4 marks. And this is what I was saying about probability, guys. You want to go in, run in, get all the marks that you need. We said that the first one was RL, and then the second one RN. So RN, so it rains and no people that are late. And then the second one is no rain and late. So those are 2 things that they are looking for. So let's look at 5.2.3. 5.2.3 says to us, write down the probability as a simplified common fraction. Big words. Let's read that again. Write down the probability, so meaning write down the chances of, as a simplified common fraction. It means whatever fraction we get at the end, we need to make sure that it's simplified. And a common fraction means that the denominator is bigger than the numerator. The numerator is smaller than the denominator. That's a common fraction, okay? It's not an improper fraction. So it says as to a simplified common fraction of randomly selecting. And that's what probability is. It's randomness, okay? Randomly selecting a learner who arrived late for school on a rainy day. So it's a combination of 2 things. Let's go look at what we would say in terms of that. So it says to us that we need to look at the probability of randomly selecting a learner who arrives late. So we know it's going to be late on a rainy day. So we're looking at this over here, rainy day and late. And it's a combination of the 2 things. So it's this over here. And we want to write that as a common fraction. As a common fraction, I want us to then look at how we would do that. It's 0.05. So 0.05. This is a basic grade 4 lesson, okay? But I'm going to do it in any case. How would I do that? If I want to take that and make that a fraction, I'm going to also go see if our calculator can do that, but our calculator can definitely do that. But let's just think, what if I didn't have this calculator with me, okay? I would say, I would look at the decimal places. I would look at how many decimals I have after the comma. I've got 2 decimals after the comma, okay? So it means that this number is out of 100 because I've got 2 decimals after that. So this number is out of 100. So it means it's 5 all over 100. Those are the 2 decimal places that I was talking about. So is that simplified? No, it's not simplified. How do I know it's not simplified? Because 5 can go into itself without leaving a remainder, and 5 can go into 100 without leaving a remainder. Our calculator should be able to do that for us. Let's go try our luck. Should be able to do that for us, but I'll tell you what to do if it doesn't give us that, okay? So it's 5 all over 100. Look at that. Stunning. It gives it to us as 1 over 20. That's a nice way of cheating, okay? It's a legal way of cheating. So it gives us 1 all over 20. If you didn't have that calculator, well, you should not come into a maths literacy exam without a calculator. So let's go to 5.2.4. 5.2.4 says to us, if the school has 1,562 learners. So now it's giving us the total number of learners within the school. I want to show you how we can do this one. So exciting. If the school has 1,562 learners, determine how many learners will not be late if the chance of rain is 25%. So now we know the chance of rain is 25%, okay? So we being asked now that when it's raining, let's go look at this. When it's raining, I'm going to clean that up again for us so that we do not get confused. So when it's raining, we want to know how many learners will not be late. So not be late is down there. And if you were to go and combine the two, it would give you 0.2. So we're going to take that 0.2 and make it a fraction. So if we make that a fraction, we're going to use that method again. So I said to you, you look at the decimal places and you can see that over there we've got one decimal after the comma. And because it's one decimal after the comma, it's going to be 10. Okay, it's 10. So that number would give me 2/10. Now I've got my fraction over there. I take my fraction and I go multiply it with the total number of learners. So therefore, 2/10 times the total number of learners, which is 1,562. So I want to go and see the part of, the portion of, the fraction of. Fraction is a portion, guys. Fraction is a part of, okay? So I'm looking for, I said it's 2/10. Let's just see if I'm doing the right thing. Yeah, it's 2/10. So I am looking for 2/10 times. So I want to multiply that with the total number. And in most cases, you will be given the total number in order for you to work with something like this. Make sure you have the total number. So that gives us a fraction over there, an improper fraction, and then it gives us 312.4. So 312.4. So now it's asking us for the number of learners. And because it's asking us for the number of learners, you need to be super careful. Can a learner be a fraction? Can you get a fraction of a learner? Can you get a percentage of a learner? No, you can't, because a learner is a full person, it's a whole person, it's a discrete, we call it discrete data. It's a whole number. So in this particular case, you would have to go and round up or round down. And in this case, because you can't have a fraction of a person, you need to round down, okay? And I find that sometimes learners have a bit of a difficulty in terms of this concept of rounding up or rounding down. So now, because we are talking about whole people, if they were saying to us, go buy tiles, and you figured out you needed 312.4 tiles, in this particular case, you'd round it up because you can't go buy 0.4 of a tile, okay? So you'd buy 313 tiles. So in this particular case, because we are talking about people, we need to go and round it down. Let's see how we are rounding it down. We're disregarding the percentage, the number after the comma. So what am I going to do there? I'm going to give this sign to say that I did round that off. So it's going to be 312 learners.